Alright, we are learning Go, right? So you might not know this, but I lost my previous record, so I have to remake it. The video contained everything up to channels. So I'm gonna remake it, but you might not notice it. But just a heads up. So we're gonna check out the buffered channels. Let's start the code server real quick. So this was um, some this was this code we were checking out last time. So it looks like we can start Go routines with just the keyword Go. Okay, how do you? I want to know how do you run on a different thread in Kotlin coroutines. You could run the coroutines on CPU thread, IO thread. They call this dispatchers. So basically, you could run on thread pools dedicated for like specific tasks. So if you have a very CPU intensive work, you could run on a like they call it default uh, thread pool. If you want to run like network request, you could run it on IO dispatchers. So I'm curious if Go has this thread pools. Does Go have thread pool like coroutines? Not really. Go's model is different from both traditional thread pools and coroutines. What Go has is Go routines, lightweight functions that can run concurrently. Scheduler, the Go runtime automatically manages Go routines and maps them onto a pool of OOS threads. Channels communicate between Go routines. When you do, you're creating a Go routine, not an OS thread. Under the hood, think of it like 100,000 coroutines, Go scheduler, 8 OS threads, CPU. The runtime multiplexes many coroutines into a smaller number of threads. So unlike some languages where you create a thread pool yourself, yeah, this is something like happens under the hood uh, if you are using Kotlin coroutines, but they expose it in a neat API. You can use dispatcher. I think what was it called? I think they it's a bit different. You just use some parameters telling what pool you want. Go already has a scheduler managing threads for use. It's a coroutine, kinda, but not exactly. Features. So this whole conversation doesn't even make sense if you aren't used to coroutine. So lightweight can suspend both. Okay, blocking operations yield. Okay, so this concept I'm not really although I can understand the suspension mechanism on coroutines, I don't know how it works in coroutines. Runtime scheduler, honestly, I didn't even know runtime scheduler was involved in the coroutine. Explicit async await. So this is a keyword. Okay. If you are familiar with JavaScript, they have async and await as well. runs on multiple threads, depends. A coroutine feels closer to a coroutine feels closer to a coroutine than an OS thread, but Go doesn't expose coroutine concepts directly. What if I want a thread pool? Visually, you create a worker pool. So we have to be explicit. We have to explicitly create the worker pool ourselves. Only 4 workers process jobs concurrently, which is conceptually similar to a thread pool. The cursed part is that Go hides most of the thread pool management from you. You spawn coroutines like they are free, and runtime figures out which thread actually runs them. Okay. Bunch of gobbledygook. I don't even understand. So let's check out the buffered channels. Channels can be buffered. Provide the buffer length as the second argument to make to initialize the buffer channel. Sends to a buffer channel block. Okay. Sends to a buffer channel block only when the buffer is full. Receives block when the buffer is empty. Oh, modify the example to overfill the. So this is some sort of like a suspension mechanism in coroutines. If you are, if you know coroutines. So this is called something called back pressure, right? You can search it. Back pressure makes it so that your whatever code or system doesn't get overwhelmed. So if you have so many like things to process and your receivers can't keep up with it, it's just gonna get overwhelmed. So your receiver is gonna get overwhelmed basically, right? So we can create a so-called buffer channel just by passing in integer, so the amount to the make function. So here they are creating a channel with buffer size 2, and they are passing 2 values. Okay. Yeah, sometimes it happens. So we need to create a channel. Make chan int and 2. So we created a channel that stores integers, and the size of this the buffer size is 2. We can send value to it. Let's pass 1 and let's pass 2. So this is how we pass values, and let's receive it. How do we receive it? Okay, so they're just printing the values. Wait a minute, just look at how cursed this is. So usually you can the direction tells you where the value is coming from, right? So the value is coming from the channel, and they're not assigning anything to it, so it's just empty. So does that mean it kind of evaluates itself to the value? Seems like that's it. So yeah, that's one print statement. Just gonna copy that and oh shit, and paste it. run it. So we should get 1 2. But let's see, if I pass another value, it's gonna suspend, I think. I don't know how to test this. How to test buffered channels in Go. Like they are blocking. Okay, my English might be terrible. A buffer channel only blocks when sending to a channel, sending to a full channel, receiving from an empty channel. Here's a simple way to see it. So we are making a buffer channel with size 2. We send it, send 1, send 2, about to send 3. Blocks forever. Okay, send 3. So if we send here, so this line, so if it blocks forever, then this part won't execute, right? Everything after the sending some bullshit, whatever thingy, it blocks. Algorithms are asleep, a deadlock. So we're gonna get an exception. The buffer size is 2, so the third send has nowhere to go. Receiving blocks when buffer is empty. Okay, so we only send 1 and we try to receive another one, but it blocks, bruh. So deadlock. This makes the blocking obvious. So we get a function. We push 2 values, and we're sleeping and receiving. So this just when we call this function, okay, so this is a go routine. So okay, they're declaring it and calling it. So when they call it, it's gonna receive 1, sending to 3, blocks for 3 seconds, send 3. So sending 3 second pass, receiving, wait a minute, blocks for 3 seconds. Why? Because we're not receiving it. That's why. The send can't complete until the receiver frees a slot. You can also inspect the current buffer usage. Length, items currently buffered, maximum capacity. So length 2, maximum capacity 5. Okay, so how do I prevent access to empty channel? I mean, like, right? And how do I prevent over buffer whatever I study one word? Usually you don't manually prevent it. The blocking behavior is the prevention mechanism. Prevent receiving from an empty channel. Just receive normally, wait until data arrives. If the channel is empty, the go routine waits. Non-blocking receive with select. So here we case 1, channel empty. If nothing is available, default runs So that's just how the select expression works. So this The select expression is this, I believe it's the same select expression used in the Kotlin. It just checks these two cases, just runs whatever whatever X is available, or invokes or whatever. So probably like checks if it has a value, prints it. The default is just this one. Prevent sending to a full channel. Just send normally, wait for space. If the buffer is full, the coroutine waits. If okay, here the same thing. Check if channel is closed. If channel, wait a minute. So this is how we check if the channel is closed. If the buffered channel has been closed, common worker pool, most Go code doesn't do if length kept to, because another coroutine can change the channel immediately after the check. Instead, you just need to use the select or simply wait until space exists. The Go philosophy is generally don't ask whether you can send or receive. Try it and let the channel block if necessary. That's why channels feel a bit different from manually managing queues in other languages. Okay, I'm just gonna save this real quick. Obsidian, let's go. Oopsie, taking some time. Let's create Go. Let's also create another folder, and let's call this basics. Another folder, concurrency. Okay, what are we gonna call this? How to prevent buffer overflow. How to use buffers in channels, I think. Okay, here let's say println fmt println about to send the third value, and right after that let's say println hello world. So this shouldn't execute, because by this time it's gonna like block it, right? Okay. Okay, fatal error. All coroutines are asleep. So we do get a fatal error. Like, why? Okay, when I try to send a value to full buffer, I get a fatal error saying it's a deadlock. That happens when every coroutine in the program is blocked and Go realizes nobody can make progress. For example, what happens because the buffer is full? There are no other coroutines that can receive from the channel. Go detects that the program can never continue. The important detail is the error is not because the channel is full. The error is because the channel is full and nobody exists who can empty it. This works fine. So wait a minute. Go function, time sleep, reads value. Okay, this works because it just makes the the buffer empty. I mean, creates a slot or something. It just takes one value from the buffer, so buffer has space basically. The third send blocks temporarily, but the receiver coroutine eventually frees a slot. Think of a buffer channel as a parking lot. Trying to park a third car, if someone is about to leave, you wait. If nobody will ever leave, traffic is permanently stuck. Deadlock. So if you're using that fatal error, ask which coroutine is supposed to receive from this channel. Usually the answer is either you forgot to start a receiver coroutine, the receiver coroutine exited early, the receiver itself blocked waiting on something else. So yeah, you maybe in the production we don't experience this kind of errors because we'll probably know where the values are coming from, where the values are supposed to be used or something like producers, receivers. You probably design somehow so we avoid the deadlock. Currently I'm just this just a test. This can obviously work fine if I have the if although though right, I did kind of receive two I did receive from the channel, so it does seem like it's executing sequentially. It's executing sequentially, and this whole thing is blocked, right? This whole thing is blocked. So this never runs, so this never frees a slot. So that's what's happening. We could circumvent this by using coroutines. Coroutines kind of exist in a separate thread or something, so they are running at the same time. Range and close. A sender can close a channel to indicate that no more values will be sent. Receiver can test whether a channel has been closed by assigning a second parameter to the receive expression after get out of get by assigning a second expression second parameter to the receive expression after like this, we can get another value. Okay, OK is false if there are no more values to receive and the channel is closed. The loop for I over range C receives values from the channel repeatedly until it is closed. Okay, this seems something we probably use a lot, right? Constantly checks values from our channel and until it's closed. Okay, only the sender should close the channel, never the receiver. Sending on a closed channel will cause a panic. Another note, channels aren't like files. You don't usually need to close them. Closing is only necessary when the receiver must be told there are no more values coming, such as to terminate a range loop. Okay, let's see. So we got channel with 10 buffer size, and we are starting a go routine, and we are ranging over the channel and printing the values. I mean, we can create something similar. And doesn't have to be, does not have to be Fibonacci, bruh. So let's just create a func. Let's call this make numbers, bruh. Make numbers. Doesn't take anything, but only takes channel. So chan int. All right, so this loops over for I, okay, I 0. Okay, let's just use range, right? Range. Okay, let's use 1000. Probably gives index and value, right? If we range over it, hopefully. Okay, declare not used. Do we need okay, this seems like very cursed. Let's ask ChatGPT real quick. How do I get a index value from range? Yeah, range works on collections, slices, arrays, and channels, not an integer. So this is invalid. If you just want numbers from 0 to 999, if you're okay, if you only need the index, what is this? What is nums? Frick. If you're coming from the language that allow range, note that Go added integer ranging. Okay, this works. In the Go 1.22, they have support for this, so we can do it. Although it doesn't give you the value, we can still use it like this. Okay, let me just print it. Print ln I. So for the testing purposes, let's just call that. See if it works. Make numbers. Although it needs channels, it's not using anything yet. Let's create channel make chan int buffer. Okay, let's use 100 buffer. Okay, so we got everything set up and it should work. Should print. Okay, now what we do is we wait time sleep. Let's use 100 and then multiply by millisecond. Okay, millisecond. And we print no, we don't print it. Instead we push it to the channel, and we loop over the channel like var I. How do we loop over the channel? So index and value from the range channel, hopefully. We don't need the index. Okay, fmt println v. Does this work? Does this work, or do we need... Let's see how they're doing that, how they're looping over it. Okay, they are not even using this syntax. So when we are ranging over a channel, we don't like we only get one value, and we don't even need to use this arrow syntax. Also, when we are done with that, what is this? How do we close it? Okay. Close is a function that takes a channel. Nice. So that way, this whatever this is knows that it can stop. Okay. This should probably... Wait a minute. So we got some sort of bug. What's wrong? Your code deadlocks, runs synchronously. Make number runs in the main coroutine inside it. The channel only holds after sending hundreds blocks because the buffer is full, but the receiver hasn't started yet because the main is still stuck inside make numbers. So fix, run the producer in a go routine. Got it, bro. Pretty easy, just use go in front of it. There we go. It be printing numbers. Alright, let's check out the select. The select statement lets a coroutine wait on multiple communication operators. A select blocks until one of its cases can run. Then it executes that case. It chooses one at random if multiple are ready. So we got the Fibonacci. Okay. So we assign value to x and y simultaneously, and we have an infinite loop, and we assign we push the value x to the C channel. What is this? A named channel. we pass quit. What is this? Quit chan. What does quit chan int mean? Is this the named parameter? So case don't understand this. Don't quite understand this. I don't understand this. Why is 0 is being used in the case? The 0 itself is not important here, it's just some value being sent to the quit channel. This line quit is a channel, right? Send an integer into the quit channel, then this case. So this just reads from a value. Wait until something arrives on the quit channel. Notice that the received value is ignored. You could write any value, and like you can access the value and print the value. Then v would be 0, step by step. So we got two channels. Two channels are created. The coroutine does for loop and then prints the value. Prints the value, I mean, which is receiving from the channel. It receives 10 Fibonacci numbers from C. After the loop, it sends a value into quit channel. Meanwhile, it is stuck in this loop. Meanwhile, Fibonacci is stuck in this loop, for infinite loop. So running, okay. The select chooses whichever channel operation is ready for the first iteration. Case is ready because the coroutine is waiting to receive from C. Okay, coroutine is receiving from C. After the coroutine prints 10 numbers, it stops receiving from C and instead does quit. So some value is being pushed to the quit channel. Now it's blocked, nobody is receiving any more. So that's because there's a for loop that receives it, but it only receives 10 10 values, 10 items. So this gets blocked. This gets blocked and it's ready. Someone is sending. So select picks case quit, prints quit and returns. And more idiomatic Go version is often they're making a channel out of struct. So they pass a empty struct, or even close quit. Because the value doesn't matter, you're only using the channel as a signal. The tutorial uses channel int and sends 0 simply because it's introducing channel before introducing struct and channel closing. The 0 could have been 42 negative 7999. The program would behave exactly the same. A bit of a reference to the Hitchhiker's Guide to Galaxy. Bruh. Okay, this example is a bit complex. Okay, there are a number of things happening here. That's why it's kind of complex. So first we got a Fibonacci function. Okay, this function like assign. Okay, are we in the same section? Okay, this function is assigning values simultaneously to x and y. X gets assigned 0, y gets assigned 1, and it's doing infinite loop, and it's using select expression. Inside the select expression, it's checking for like it's receiving value from what is this? Okay, no, it's uh it's not receiving value, it's pushing value. It's pushing value to C channel infinitely, and then and then they kind of reassign values. So the x gets assigned a y, and the y get assigned x plus y. So this is a Fibonacci. It's just a little bit of overhead to kind of wrap around this function. It's using select and it's doing Fibonacci. Fibonacci is just a random garbage. You probably want to ignore it. K squared. So it's not reading the value from the it's reading value, but it's accessing value but not assigning. In this case, just prints it and exits from the function. So we have a go routine here that reads 10 values from the channel. So they're just looping for 10 times and reading values from the channel 10 times basically, and then they push a value to the quit channel. So here this does not have this is not a buffer channel, right? But this gets blocked because no one's receiving it, and this runs because there's a value in the quit channel basically, right? Let's try to recreate it, but let's not use the Fibonacci, bro. So we need a way to continuously send a value to a channel, right? Where is it? If we call make numbers, this kind of like send values to this ch channel. Let's try to read 10 values from the channel. Okay, let's use I 0, I still less than 10, I plus plus plus, and then we just read from the channel. Okay, so this is the channel. We read from the channel. Let's use the for loop. Okay, we already have a for loop. We are sending values, but so what's the problem with this? So this loop, we don't have a way to break out of it, right? It's just gonna run until there's no way to break out of this unless we specifically check a condition and then return from here, right? So they're doing the for loop, they're using case, and they just use the expression in the case thingy. Like, what is this? So we got a case keyword, and then they use the expression. So what value becomes? So if we use it like this, So this is kind of very weird syntax. You might have not even seen this in any other language. So what's happening? I thought cases are static values. Select is very different from switch. You're probably okay. You're probably thinking of a switch statement with case, where cases are static values being compared against hex. But select works on channel operations, not values. Each case is a channel sender receive operation. In your code, case means if I can successfully send X into channel C, do it and then run this block. Okay. It's roughly send to channel and some Fibonacci math, except it only happens if the send is ready. Send is ready. So, okay, can I send to C? Can I receive from quit? If multiple are possible, Go picks one randomly. If only one is possible, it picks that one. If none are possible, it waits. This is basically, yeah. Okay, cool. Okay, now we know how to do it. So we can pretty much like use the select expression. So select and use this. So case. Let's use the case and use it like this. But what do we put? What do we put after it? So I only want to send a value to the channel. I don't want to do anything else. Let's just say println sent a value to the channel or something. Okay, let's do case quit. So quit, you probably don't need that. fmt println quitting. Let's say quitting and return. Now we do need like another channel. So quit channel integer. Okay. We don't need the close channel. Dude. Anyway, like if you're using code server, you can use Control-Shift-I to format the document. So let's create a quit channel. Make chan int. Let's pass that here. Quit. After this, let's pass value to the quit channel. We get quit channel, pass value 0. Okay. Although we have like 1000 iteration. This should only iterate for 10 and then return. Let's see. Sent a value to channel 4. What's happening? For loop can be modern using range over. I don't understand why it only printed 4 values. Okay, could it be the main function closed? Seems like the main function just closed before our program can complete. So that's my speculation. Did the main function close before my code could complete? The problem isn't the main exited too early. The problem is that you are sending to ch twice per loop iteration. What is this? Oh shit. My bad, bruh. Okay. Seems like it's working. Yeah, this we want to make like equal to 10, so we get 10 values. Boom. Let's just ask ChatGPT to write me the node for this. Create a node on select. Use my example. ChatGPT app kind of looks dog shit compared to the web version. I guess it's fine. Select okay, this is called select, bro. Alright, let's look at default selection. The default case in a select is run if no other case is ready. Use the default case to try a send or receive without blocking. Okay, so we got a case where we receive a value from C, and then we use the value high. But the default value for the default case we can receive from C uh, even if it would block it or something. So this is a bit of a long one. Let's see what is happening with this. Okay, so we get a main function, and then we have a star. We are trying to measure or something, so we get the current time, and time package as a tick method. What is that? That measures 100 millisecond. So 100 millisecond is one tick. Time after 500 millisecond. So this is the boom time. Elapsed, we got an elapsed function. Anonymous function or something. What is this? We got a function that has empty parameters, and then we got a time duration. Okay, time duration is the return type here. It returns time since start, round time, a millisecond. So we are essentially trying to find how long since the start time, essentially, and then we round it to millisecond, and everything is time duration. The type is time duration. Okay, and then we have an infinite loop and select. Although we don't have a value, like, what is this? There is no channel, but why can we do this? There is a channel. It's just easy to miss because tick itself is a channel. For example, tick returns a channel of type white. Okay, this function tick returns a channel of type channel time. So this is actually pushing some value to some t, except you are throwing away the received value. So the tick method returns a channel. Every 100 millisecond, the Go runtime sends a time value into the tick channel. Okay. So if we use this format specifier, percentage t, we get the channel with the type of something. Okay. So essentially, this garbage, the time tick, is a channel. What about time after? Is time dot after also a channel? Time after returns a channel to A signature is channel time. Notice that return type. That's a receiver only channel of time values. When you write, you're basically saying wait until a value arrives on the channel returned by time after. After 5 seconds, the runtime sends a time value into that channel. What value? So it's conceptually similar to creating a channel with one buffer and no, not doing anything. It just sleeps for the duration you specify and then passes the current value, current time to the channel. Okay, but elapsed is it's not a channel. So if for the first case, it's gonna like read the values from the tick channel, and it's using this what is this? Printf elapsed. I don't know, it's just printing some value. And then when it receives from the boom, it prints the boom and then returns. For the default value, they're just printing elapsed and then sleep. And they're sleeping for 50 milliseconds. I guess that would, if they didn't use the sleep value, the default case will run forever or something. Okay, we need a tip and boom. Okay, let me just I'm just gonna copy. Okay, I thought I would copy it, but let's not do that, bro. Okay, func main tick. Okay, so I wrote the code. I found on the default selection. So this timed tick method returns it actually returns a channel, like it pushes its values to the channel, and boom, I mean the after method also pushes values to a channel. So these two actually return as you can see here, they both return a channel. So tick and boom both are channels. Elapsed is not a channel, it's just it just returns a time duration. So it takes, we're calling since method, passing a time, and then we're just rounding to millisecond. So we have an infinite loop, and we have a select expression, and then we are in the select expression cases, this case is different from switch case. So the value or whatever you can use in the case are send or receive channels. So when we use it like this, and if we don't put anything in the direction of the arrow, it means we're just discarding the value. We don't care about the value. So this is a very like special format specifier. So this takes a string and pads until we get like 6 character or something. The same thing, it checks the, like, these are all like, these two check for the the tick channel and boom channel until they are like blocked or something. We're calling it elapsed, and yeah, it just prints the elapsed values. Okay, the point is, it doesn't matter the elapsed function. Elapsed, well, technically what it's doing is pretty simple. It just takes the start time and then it's measuring how long are we from the start time, basically. So that's elapsed, right? It does kind of seems very weird. It's not intuitive. So you have to remember to use since and pass the start method, and then need to round it to millisecond. So the default value, when both of them are not active, the default case or whatever runs. Same thing, it's just printing the elapsed, and importantly, it sleeps. It sleeps for 50 milliseconds. Okay, so if you don't sleep, the CPU is gonna keep on like running forever. It's just gonna like that's really bad. You don't want to run some code, some goofy looking code forever. Okay, let's just run it. Oh, my bad. Go run. The reason like it stopped at the boom, well, it's because we are returning out of the for loop. Okay, crazily enough, the power goes out. Now the tablet comes in handy. Alright, let's look at exercise. Equivalent binary trees. There can be many different binary trees with the same sequences of values. What the hell? Okay, stored in it. For example, here are two binary trees storing the sequence 1, 1, 2, 3, 5, 8, 13. A function to check whether two binary trees store the same sequences is quite complex. In most languages, we'll use Gauss concurrency and channels to write simple solution. This example uses a tree package which defines the structure left value right. Continue description on next page. Exercise. Equivalent binary trees. Implement the walk function. Test the walk function. What the hell is this? The function tree new constructs a randomly structured but always shorted binary tree holding the values k, 2k, 3k, 10k. Create a new channel ch and kick off the walker. Then read and print 10 values from the channel. It should be numbers 1, 2, 3 all the way up to 10. implement the same function using walk to determine whether t1 and t2 store the same values. Test the same function, should return true, and tree new1 new2 should return false. The documentation for tree can be found here. Dude, honestly, I don't even understand this question. What is this? Sync mutex. We've seen how channels are great for communication among Go routines, but what if we don't need communication? What if we just want to make sure only one coroutine can access a variable at a time to avoid conflicts? This concept is called mutual exclusion, and the conventional name for the data structure that provides it is mutex. Go standard library provides mutual exclusion with sync mutex and its two methods, lock unlock. We can define a block of code to be excluded in mutual exclusion. We can define a block of code to be executed in mutual exclusion by surrounding it with a call to lock and unlock as shown in the inc method. We can also use defer to ensure the mutex will be unlocked as in the value method. What's going on here, bro? Package main, safe counter is safe to use concurrently. Safe counter. So mutex, mu, which is a type of mutex, I guess. V, which is a map string to values. Inc increments the counter for the given key. So this is a method on safe counter, pointer type, takes a string key and then calls mute lock on it. So lock, so only one coroutine at a time can access the map CV. What the hell is CV? Okay, increase the key, so we access the value using the key and then increase the value and call unlock. Value returns the current value of the counter for the given key. Okay, safe counter value. Okay, value returns current value of the counter for the given. Okay, lock, so only one coroutine at a time can access the map CV. So they are using defer unlock. Okay, so the defer unlock runs at the end of the block. So this is the way we are calling it is same as like this. So we just put it some in the middle of nowhere so it runs. So safe counter, and for the v value we're passing a map. Like what is it? V, what is v? So v is a map that maps string to integer. So we create a map it does look like it's an empty map, and then we loop over 1,000 values, and then we call our go routines on the C and some key. Okay, this is very like complex looking example. what's going on here. This is Go's classic example of protecting shared data with a mutex. The problem it's solving is maps are not safe for concurrent writes if 1000 coroutines try to update the same map simultaneously. Okay, that's the reason they are using like for loop here. Okay, that's the reason they are using for loop here. So they are literally launching over 1000 coroutines and they are accessing some key. Okay, my question is, we don't have some key, right? I don't know, bro. Like, maps are not okay. Fatal error. So if 1000 coroutines try to update the same map simultaneously, Go will eventually panic with concurrent map writes. So sync mutex is used to ensure only one coroutine accesses the map at a time. The struct. So safe counter contains mu and v contains a lock. So a lock, the actual data increment. So when we call the increment with key, it uses the key to look into the map and increase the value. Okay, so if we have so many coroutines like this and they basically like access try to increase the map, access the map or something, so it acquires the lock, it writes it, but second coroutine waits for it, and then and then increments and locks. Coroutine gets the lock, increments, unlocks. So they basically take turns. Only one coroutine touches the map at a time. Even reads are locked. Why? Because while one coroutine is writing, another coroutine might be reading. Go maps are not safe for concurrent read-write either. Okay, now let's look at this. Safe counter. So this is the structure and the actual instantiation or whatever you might call it. Creates map string int then some key. Starts 1000 coroutines. Each coroutines eventually does so some key is equal to 10,000. Why the sleep? Without this, main would probably print before most coroutines run. Depending on the sleep gives the coroutines time to finish. Okay, let's ask my question. We don't have some key value in the map. How can we access it? When you do, the key doesn't exist yet, but Go maps have a special behavior. So this is just the empty map. When we try to access some key that doesn't exist, it gives me 0 for numeric values. A missing key returns the 0 value of the value type. So this is effectively assign the garbage, and since return 0 when missing, the first increment becomes 0 plus 1. Now the map contains some key plus 1. The second increment becomes some key plus 1 plus 1, and so on. If you want to know whether a key actually exists, use the comma. Okay, v is the value. Okay, is the true if key exists. So a missing key and a key whose value is actually 0, both written 0. The OK tells you which case you are looking at. So this is actually a weird behavior of Go. You can still access a map even though it doesn't have the key. All right, let's try to write this. Okay, it was pasting some garbage. If you want to circumvent it, you can use Control X. This just cuts the selection, or you can use the Firefox. You can press backspace 2 times to delete it. Okay, let's create that mutex thingy. So we need a struct. Let's create that type of. Okay, let's call this my struct, my map or something, bro. I don't know. Okay, we need mutex sync mutex. So what is it? It's sync mutex. Bruh. Sync mutex expected type found. Okay, we need to struct. Probably we need to import a sync package. Mutex. And then a value, which is a type of map. Map string int. What is this? We can then create a method called increase takes like m my map inc takes a key string. This goes to map v, uses the key and increments it. How do we acquire the lock? So here mu what value does it have? Oops. Okay. We need to use m mu dot lock and then m mu unlock. Now we can create, select everything, Control Shift high. Now we can go for loop, for high range. We can just loop over it and create go functions. Like we need let's just test map. It's just my map with like make map. What the hell? How do you create an empty map? Make map string int. For the v value, so what are we using? I'm using v, same thing. Make map string int. Okay, so we got test map, goroutines func that tries to test map calls inc. The key is some key, and then calls it. We ignore. We can just range over it like this, I guess. Creates 1000 goroutines and increases some key. So after this, let's see, fmt println test map v. Okay, let's just print that after it's done. Go run dot. What's going on? What's wrong? You are printing before coroutines finish. Go starts coroutines and immediately returns. So FMT runs almost instantly, usually before any coroutines increments the map. You need sync wait group. You are reading the map without locking. This is subtle. Your inc method protects writes, but here you're reading the map directly without the mutex. If coroutines are still running, this can cause concurrent map read and map write. You should provide a read method. So we do need to provide a read method. Then so this is the complete version. Let's just copy this, bruh. And try running it. Try running. Get away, man. Expected package found type. Bruh. Package main. Let's just import all of these garbages. We need to import it, but how? Quick fix import. Did it import it? Nope. Did it import it? Bruh, it's not even importing it, bruh. Like, sync. Okay. Okay, so we need to create a wait group, like how ChatGPT said. It's not complete version. It's not using the wait group. Okay, didn't I copy this? The complete version. I might have not copied the complete version. So it has increment and a way to read the value, and then it uses sync wait group, creates a wait group and uses wait. So it should read 1000. Cool. So we are supposed to use the wait group. What if we just, since we already have the wait group, what if I just access the V? Okay, this also works. Alright, so we looked at the mutex and lock, unlock. So I'm gonna end it here.